Guys, in this video I'll cover multi-threading. I'll start out by briefly explaining what a thread is. Then I'll demonstrate how to create a new thread by extending the thread class. And then I'll demonstrate how to create a new thread by implementing the Runnable interface. And this can be done by creating a name class, an anonymous class, or a lambda expression. Let's start out with step 1. I add a comment here, and this comment illustrates the idea of threads. Now we always have a program. That program has statements, and when we launch that program, the operating system creates a process with a main thread. This is my thread 1 here. That thread will execute these statements line by line by line. Now every program doesn't just have instructions for the computer to do, but it also manages memory. And the memory is split up in stack and the heap. The stack keeps track of local variables, of arguments, of the function calls. So whenever we call a function, a new element, a new frame gets pushed onto the stack. And then any local variables that are created in that function will be stored on the stack. And when the function finishes and returns, the stack will also store the return address. That is the line to go back to and continue the execution. The heap will store any objects that we create. Anything that we create with new will be stored on the heap. Now, if we have very large programs and we have tasks that can be split up, we can create additional threads, and those threads are essentially workers that help us execute the same instructions on the code. Each thread has its own stack to keep track of where it is and how to return from function calls and the local variables and functions. But the heap is always shared among all the threads. So when dealing with multi-threading and with multiple threads that access objects and memory on the heap, we have to deal with synchronization. I don't go into synchronization in this video. Instead, here I only talk about how to create additional threads. So let's move on to step 2. Let's create a new class, and this class will extend Java's thread class. I call my class here my thread. And whenever we create a thread, we need to override the parent method. This one is the run method. And the run method has all the instructions that we want this program to do. Now what I want to do here is I want to sleep a little bit. So I create a private member variable random. And then I call here the milliseconds. So I use random.nextInt. And I want to sleep for something around 500 milliseconds. Now nextInt returns positive or negative. So I use the absolute function to bound this to only positives. And then I call thread.sleep. So what thread.sleep will do is will actually cause my program to sleep at this time. And after the number of milliseconds after this sleep time period is over, it'll wake up and continue execution. And after that, I output a message to the console. Let's output getName. So getName gives me the name of the thread. And I just output the thread name is running. Now, I don't really need all of this, but I want to kind of randomize it so that every thread that I create sleeps for a random amount of time before it outputs the message. And this is all I have here. Now let's create a few instances of this class, and I start out by creating a very simple one first. So I define a variable of the supertype class, and I instantiate it with an object of my class here, my thread. And now I want to avoid the common pitfall. This is by calling the run method. If I call the run method, it will simply make a function call to this method, would execute it, and then finish the program. It would never create a thread. What has to be done instead is call the start method. Start will internally create a new thread, and once the thread is ready, the run method will be called automatically, and it'll execute that on a separate thread. So let's run this program. And here we can see thread 0 is running. So thread 0 is just a generated name for the thread. Now let's create a few more. Let's do this in a for loop. And run this again. So now we can see we get up to 10 threads. And all these threads execute in different orders. That is, the reason for this is that I put in the sleep method, so they sleep a random amount of time before they start running. And this now has a program where I created 10 threads in addition to the main thread. So this was step 2. I took the thread class that Java provides, I extended it with my own class, and then I can implement anything that I want the thread to execute inside the run method. Next, I want to show how we can do the same thing by implementing the Runnable interface. So I do this here. Call this my Runnable, and it implements the Runnable interface. The Runnable interface also has a run method. So essentially it's the same what I have above. And because it is so similar, I just copy the code over. And so this is what it looks like. Everything is the same. The only thing is, instead of extends threads, we do implements Runnable. Now I cannot do getName because this class doesn't have getName, but what I can do instead here is thread.current thread. This gives me the thread that is currently executing my program, and on the current thread I do getName. So I still have the exact same functionality that I got when I extended the class. Now let's comment the code that I had before, but let's do something similar. Now I do thread, my thread, new thread. Now I create an instance of the Java class thread, of the Java thread class. And here as an argument, I pass in my Runnable. Actually, my Runnable like this. There we go. And then I can execute this by calling the start method, not the run method. So let's run this again. And here we go, thread 0 is running. We could also do this in a loop like we did before, but the only difference here is I pass in my Runnable to the thread class. This is the preferred way of creating threads. So it's always better to implement Runnable rather than extending the class. The idea is that we are not really making any changes to the thread itself. We really want to just provide some code that the thread should execute. So it's always better to implement the interface and favor composition over inheritance. Now I mentioned there are 3 ways of implementing Runnable. I just did the name class, but we can also do here step B and C, so create an anonymous class or a lambda expression. So this is with a name class that implements Runnable. We can do it with an anonymous class. And this would be thread. I call this my thread 2, new thread, and new Runnable, and then just basically defining the body of the class right here. I have to implement the run method. And here, I just keep it very simple. I just output running my anonymous class. And next, I can do the same with a lambda expression. This one I do thread, my thread, 3, and again I create a class of thread and provide it an implementation. Now with lambda expression, they work with functional interfaces, so Runnable is a functional interface. It only has a single function named run, so I can provide the implementation here. There are no arguments, so it'll be open close parentheses and then whatever I want to execute. I could do that in curly braces. Most of the time it'll probably be in curly braces. Unless I have just a single statement, I can just do the single statement too. So that should be it, and I have to launch this one too. My thread3.start, and here I forgot this with my thread2. I launch this one too by calling the start method on the thread. Now let's run this. And here I executed all 3. And the first one actually executed last because the first one again had a sleep method a call to the sleep method that it randomly slept for a certain amount of time. And we can see also that these get executed as a thread, because if this would be a regular function call in the first one, it would just sleep and it would stay and wait there, and then execute this one whenever it's done, and then continue execution. Here, each of these start methods spawn a new thread, and all these threads work and run concurrently. So that is everything I wanted to cover in this lecture. I hope you enjoyed this lecture. Thank you for watching.